So we start with creating our database. I mean, in this old website, like which is the target of our data source, there are hundreds of lines of earthquake logs here. So we need some place to store this data, and the data here is quite valuable. And there's this timestamped, and then latitude, longitude coordinates, the depth of the earthquake that occurred, and the magnitude and the location. So it's not presented quite nicely, and that's our purpose. We are creating this application. So I just need a database first. So I had to DynamoDB here, and I chose DynamoDB as an SQL database because, as it says here, like it's fast and flexible. I like the performance of the DynamoDB table, and I can also change very easily like some of the attributes that I would like to include or remove, or I can add some other tables for a new feature. So before I click the create table button here, I would like to explain a few things. And this is we are back to our diagram, the architecture of our application. So we will be working with the data ingestion part first, and as you see, the data flow is from left to right, but our implementation flow will be from right to left. And when I first saw this, when I was learning AWS services, and I saw similar diagram for some sample project, and I was surprised that the developer, she started from actually from the opposite side of the data flow, and I was a little bit puzzled. So therefore I'm making this explanation to you. So assume that we start with the event bridge first. Let's assume that we will implement this first. So that we will implement a schedule here which will run every 10 minutes, and this schedule will start the Lambda function. But if I haven't created my Lambda function already, so that what will this event bridge schedule will do? So that's a problem. And the same way, like this Lambda function will download some HTML file and assume that I'm implementing the Lambda function before DynamoDB table. So eventually it's supposed to write the data into a DynamoDB table, so that, but we don't have a DynamoDB table yet. So that will be pausing my work while I'm working. So therefore, we go from right to left, and then we will first create our DynamoDB table. Later on, I will create a Lambda function to fetch the data and store it to the database. And later on, I will set and configure an event bridge schedule so that this will happen automatically once in every 10 minutes or maybe once in an hour. So let's go back to the dashboard of DynamoDB and then click create table, and I give name EQ log. So don't be surprised with the EQ. I will use this abbreviation quite often. I just refer to earthquake, and earthquake is a long word, so that's why. So we are supposed to give here some partition key, and partition keys must be unique. And while I'm actually like utilizing the DynamoDB table, I want to use many like advanced features of the DynamoDB, because what I need is I will keep this data not forever. I will keep it for like one day, and I will show you how you do it later on, because I want my application to deliver the data like instantly, and I don't want to keep actually lots of data here. Maybe I will only scrap like the first 100 logs of this website, and later on I will delete them with some time to leave attribute in the DynamoDB table. But I won't make any complex queries here, so I will use always like scanning, and I will just get all the data that's available on my DynamoDB table. So I'm writing here, like I will call it timestamp, but I will not actually use this timestamp like a query key. I mean, and timestamp, I mean the partition must be unique, so that we are assuming that there will be no earthquakes that are happening exactly at the same second, a minute and second, so that I think we are quite safe. So we head to the table settings, and I think we should customize our settings for our use case. And I'm planning to use like DynamoDB standard. And we don't want to have an on-demand, but we want to have some provisioned database so that we can avoid some of the costs while we're implementing. And the top one is the auto scaling. I will set both my read capacity and write capacity auto scaling off, because I mean, I don't think my website, my earthquake monitoring application will be a hot shot and it will be popular, but you never know. So therefore I just don't want to use so many resources from my AWS account so that I won't get a huge bill. So I'm reducing like the possibility of like too many people like coming to my website, and I would recommend you to do the same. So I don't need 5 capacity units either. I think 2 of them will be enough, because you can look it up at DynamoDB white paper. So that according to the white paper, so that the capacity units for, I think, read capacity, it's like 1 unit capacity will fetch you 4 kilobytes of data. And maybe I'm just wrong, or like 2 units with 4 kilobytes. So, and I think this is more than enough for our use case. So therefore I just set this capacity units to 2. So we don't need to touch this warm throughput or any other thing, I guess, here. So we don't need deletion protection, and we don't need any encryption either, because we are working with some public data. And so then we just hit the create table, and this process will take a few seconds, and it will be just creating my table. And after this process is complete, I will just add some random data. And so now it's done, it's ready. So I just want to add some random data, because I need to define an attribute which will be used as time to live parameter. So everything looks good here. It's like time to live TTL, its status is off. So I just want to turn it on, but maybe first I just want to add some data. And we can click on explore items, and we can create item. So timestamp here, I mean, it doesn't matter what I write here right now, because I won't be using this data. It will disappear. So, and then we can add new attribute like magnitude. Our Lambda function will do those things later on, but I just want to show you some example. And then this will be a number. Actually, I did something wrong here. So let's do this like a number, because I will keep my magnitude of the earthquakes as numbers. So let's assume that it's 2.4. And then we need to add location as a string. Oops. Let's assume the location is Istanbul. And the depth, again, it will be a number. Depth of the, it's like 6.1 kilometers depth. And then we can add longitude, which will be also number. These are like the coordinates, longitude, and it might be something like this. And number, latitude. I mean, maybe I'm just losing time here, so it doesn't matter. But I will add now the attribute that I actually really need. I just want to visualize things for you. So I will use an attribute called expiry time. And this will be an epoch value. So we can use epoch converter. And right now, I will just pick this one, and I will add some, increment this number like to 900 something. So I will just create item. So we need to set up this. Now we have only one item at our table, and I just want to set up this TTL thing, and I'm just here, turn on TTL. So I will use this attribute name that I defined, expiry time and epoch time. For example, you can preview what data will be deleted. Run preview. Yes, this is the data because I just used added some few seconds to this expiry time, and it will be also deleted in the next 7 days, of course. So this is quite helpful, like this run preview thing. It's quite good. And expiry time works this way. So you define here an epoch time, like Unix timestamp, and then you give it with the rest of the data. And when you set the TTL on, so that it just looks up this attribute that you define here, and then when the time is up, it just deletes that row. So that's it. So this will be helping us not to store so much data, because I don't want to keep some historical data which will increase the costs for me. So now we are, I think, good to go. So soon the data that I have will be deleted. Maybe it's already done. I just didn't calculate how many seconds, but soon this log item, it will be just deleted. And I think we are done with the DynamoDB table setup. So now we can move to the Lambda.